Okay, so next topic is algebra and properties of integrals. So, let's see. We already started finding the antiderivatives, and we know that if we have some extra information, we can actually figure out what the C's and the D's are. So, we can also solve the antiderivatives if we have slightly more complicated integrals if we use some algebra techniques. So let's look at this example. So if we had x to the 6th plus the square root of x minus 2x over x to the 4th, and then we have dx. Alright, so it's not just x to some power, so we can't take the antiderivative right away. However, we can do some algebraic techniques to make it x to some power. So here we go. Let's actually, since we have only one term in the denominator, we can do x to the 6th divided by x to the 4th plus the square root of x divided by x to the 4th minus 2x divided by x to the 4th. We can do that because we have one term in the denominator. If we had two, we couldn't separate it like we just did. Okay, so now we can simplify, and x to the 6th over x to the 4th simplifies to x squared plus, let's write this next one as x to the 1/2 over x to the 4th, and then the next one we get 2, and then if you imagine there's a 1 up in the exponent, we got the base numbers are the same, so that's when you subtract. So you get 2x to the 1 minus 4, which is negative 3. And then we have dx. Okay, let's simplify that middle term now. So we get x squared, and then plus x to the 1/2 minus 4. So that gives you minus 3.5. We got minus 2x to the negative 3, and then we have dx. Alright, so now we see that there are all x's to some power. So we can do the power rule for integrals. So here's the antiderivative. We got x, and then 2 plus 1 is 3, and then the coefficient is 1 over the new exponent. Next we have x to the negative 3.5 plus 1. If we do that in our heads, we get negative 2.5. So our coefficient is 1 over negative 2.5. And then we have minus 2. It's along for the ride. We got x to the negative 3 plus 1. And that, if we do that in our heads, is negative 2. So our new exponent is negative 2, and our coefficient is 1 over negative 2. And then we have plus c. Now let's clean it up. We got 1/3 x cubed, and then we have a minus, and then we have 2.5 in the denominator, which is a little weird. So let's do that off to the side. So we do know that 2.5 is 5/2. Is that right? Yep. And then what we can do is multiply by the reciprocal here, and then we get 2/5. So 1 over 2.5 is equal to 2/5. And then we had negative 2.5. And then we have the minus 2 cancel, which is really exciting. And then we have plus x to the negative 2 plus c. And there we go. We can actually leave it like this if we wanted to. And there we go, that's our integral. Okay, so sometimes doing algebra helps you solve antiderivatives. Now, the last thing that I wanted to mention was some properties here. We've been using some of them. but let's really just mention them for clarity. So we got our first property if we're integrating a function and there's a coefficient out front. Bet you can guess we can take that coefficient out and then integrate the inside portion. Alright, next is if we integrate and we're adding two functions, so f of x plus g of x. Okay, so what we can do is split it apart. And that's really great. You should be thinking about with the derivatives. We can do that also. Maybe I'll just say recall. Got the derivative equals, take the derivative of the first plus the derivative of the second. So that's like same story here, and it's really nice. Also, if you go to subtract, that's just the integral of the subtraction. Okay, and same story there. Okay, so we talked about addition, subtraction. The next thing we wanted to mention would be multiplication. Now, it would be really nice if you could just split the integrals apart. However, it's impossible to do. You can't do it. So there's no simplification here. And we're sad because, alright, it would be a lot easier, but that's actually why Calc 2 exists, is to find the integrals of these different things. And just while we're thinking about it, if you recall, if you go to take the derivative of two functions, it's the product rule. And because it's the product rule, because it's more complicated, we can't integrate nicely here. So there's no simplification that we can use, no specific properties, and then same story with division. No simplification again. And that has something to do with the quotient rule. The quotient rule is so complicated, we can't take the antiderivative of it. Okay, so that's actually why we have Calc 2. So we'll get around some of this, but there's some more steps. We got to get more familiar with the integrals to figure it out. Okay, one last thing that I wanted to talk about is, let's suppose we integrate a derivative. What would we get? Well, we know we get the original function, but then we had to add that c there for the constant. So if you integrate a derivative, you almost get back the original function. But it's going to vary with that constant. So keep that in mind.